Hey everyone, today we're going to be covering chemistry review. Some of this is just very nice to review, and other it's going to appear later on in advanced chem, so I want to make sure that I really hit up on it. So let's go ahead and get started. The first one is properties of matter. Oftentimes in labs, you're required to describe what something looks like or feels like. Can it react with something? Does it not react? So it's good to kind of cover this basis. We're going to first talk about the difference between extensive and intensive properties. Extensive depends on the amount of matter that you have. Do you have a small amount versus a large amount? Things like mass, length, height, even something like volume is all going to be dependent on how much you have. For example, mass is going to be less if you have a little amount or large if you have a bigger amount. Same with volume. How much space does it take up? If you have only a little bit amount, it's only going to take up a certain volume versus a large amount. Intensive, which is honestly the most important of these two, does not depend on the amount of matter you have. And oftentimes, these properties are used to determine what is your unknown substance. Things like color. You can have a small or large amount, the color is going to be the same. Density, boiling point, melting point. You can have a glass of water or you can have a gallon of water. Both of those are going to boil at the same temperature. The other type are physical versus chemical. Physical properties, these are things that can be observed or done without changing the composition of a substance. So remember, composition is what it's made up of. For example, color, odor, density, melting and boiling point, hardness, if you change its shape or cut it in half and change its size, or even change it from a liquid to a gas, these are all being done, but what you're working with is still the same compound. I can see that water is clear, but it didn't change what it was. I can tell you water doesn't have too much of a smell, it still didn't change what it was. Chemical, on the other hand, does change the composition. So if I go to check the flammability of something, or if it reacts, or if it rusts, these are all going to change what it's made up of. For example, another one is production of a gas with baking soda and vinegar, or even formation of a precipitate. So remember, a precipitate are solids that form from two liquids. And we'll see precipitate actually when we get to solutions, our chapter we cover there. The next one I'm going to cover is states of matter. This is always just a nice review. Specifically, we have a whole chapter designated to gases, so I kind of just want to go over the basis of a gas. Our three states of matter are solid, liquid, and gas, and we can define them by looking at their shape and volume. And we can say if they're definite versus indefinite. Looking at the shape, solids have a definite shape, which means it does not change. If you put a stapler in a room or if you put a stapler in a desk drawer, it's going to maintain that same shape. However, liquids and gases tend to take the shape of whatever container they're in. If you move them from a bowl to a cup, they're going to change shape. In terms of volume, solids and liquids are the ones with the definite volume. Their volume is going to be the same, or they're going to take up the same amount of space no matter where they're at. Whereas gases tend to expand and take the shape of their container or their room. So they are considered indefinite. In terms of the question, can it be compressed? Compressibility has to do with how much space is in between those molecules. And solids are so tightly packed together that they cannot be compressed or squeezed into something smaller. Liquids, not really, but there is still a little slight give just for the fact that there is a little amount of space in between those liquid particles. And gases can be very easily compressed. And the reason is there's so much space between atoms. On the periodic table, these can all be identified based on their color of the letters. So if the colors of the letters are black, that means it's going to be a solid. If they're blue, they're a liquid, and there's only two, bromine, and the other one is mercury, and gases are going to be red. From there, we move on to classifying matter. Do we classify it as an element, compound, or mixture? Now that we're in advanced chem, these are going to be the two that we work with. An element is something that cannot be broken down into something smaller without compromising its chemical makeup. These are represented by chemical symbols. So these are things like hydrogen or oxygen. We have gold, silver. These are all on the periodic table. Compounds, these are two or more elements that are combined chemically, and usually they're represented by formulas. So sodium chloride is sodium and chlorine together. Water is hydrogen chemically combined to oxygen. And the last one, mixtures, these are physical combinations of two or more substances, but they're combined in a way in which each of them retain their own chemical identity. Now, there are two types of mixtures. Heterogeneous, these is when you have two things mixed together and you can tell the difference between what's mixed together. Homogeneous, this is where you have uniform throughout solutions or they all look the same. Typically, the most solutions that we work with are things that are diluted in water. Moving on, we have our periodic table. Our periodic table is just an arrangement of elements in which the same elements are put into the same groups based on their properties. And they're organized by the atomic number. Remember, your atomic number is your number of protons, and this is unique to each element. Groups are vertical, which means they're going to run up and down. The reason they all have similar properties is because of valence electrons. Remember, these are the electrons in the outermost energy level. And the way we determine valence electrons is its group number. So if it's in group 1, it's going to have 1 valence electron. For example, chlorine is in group 7, so it has 7 valence electrons. Calcium is in group 2, so it has 2. The only exception is helium, even though it's in group 8, so group 8, it actually only has 2 valence electrons. Periods, these are ones that go horizontal or left to right. They all have the same number of energy levels, but their valence electrons are continuously increasing by 1 as you go left to right. Over here, I put this picture up because one thing that you need to take in is understanding the group names. You're going to have assignments where I'm going to say, oh, all the alkali metals are an exception. And you have to know, well, what group are alkali metals? Or I'm going to say all the halogens have this characteristic for some things that we work with. And you need to know which group are the halogens. So here, alkali metals are yellow. Alkaline earth metals are this purple color. Here we have our halogens. Here is our noble gases. The light blue is your transition, and then the purple at the very, very bottom, which is a little bit different shade, are your inner transition metals. Here's a little chart that I've taken from the chemistry textbook to show that most of the periodic table are metals. Here we have metalloids, which is our green staircase, and then our nonmetals are located in blue. We're going to talk about these. Understanding the difference between metal and nonmetal is very important. So a metal is something that's a good conductor of heat and electric current. Most of them are solid, as you kind of seen. They're ductile, they're malleable, which means you can bend them. Bend without breaking. And note they are left of the metalloids minus hydrogen. So if we look at this, metalloids are here, they're everything to the left. The only exception is my hydrogen over here. Nonmetals, these are usually poor conductors of heat and electric current. A lot of them are gases, And if they are a solid, they're pretty brittle or they break very easily. These are to the right of the metalloids. So if you find the staircase, everything to the right, which is this blue, plus hydrogen over here, is your nonmetal. And then metalloids, these have properties between metals and nonmetals. It depends on the conditions, and that's that little stair step that you see. On my periodic table, remember, those are the ones with the green triangle in the corner. Now, in terms of looking at these, you should be able to look at a periodic table and classify these elements. I want you to try to pause this video and see if you guys can classify them yourself, and then let me know what you guys think. So hopefully you pause this video. Let's go through and see if you guys have the right answer. So phosphorus, this is actually going to be a nonmetal. Strontium, this is a metal. Germanium, this is going to be a metalloid. Sodium is a metal. Aluminum, also a metal. Boron, this is a metalloid. Carbon is usually what surprises a lot of people. This is a nonmetal, and hydrogen is a nonmetal. How'd you do? From here, we can talk about the structure of an atom. If you do not have down protons, electrons, and neutrons, I'm sorry, you probably need to really come in for help or talk about dropping the class. Structure for the atom, there's 3 subatomic particles, protons, electrons, and neutrons. Protons are positively charged, they're located in the nucleus. Electrons are negatively charged, they're outside of the nucleus in orbitals. And the neutron are neutrally charged inside the nucleus. Please note that the proton and neutron are about same size, but here my electron is very small. From there, we look at our atomic number. Our atomic number is the number of protons in the nucleus. This is unique to each element. This is how the periodic table is arranged. The next one you have is your mass number. This is protons plus your number of neutrons equals your mass number. And then you can determine the number of neutrons quite easily by subtracting mass number minus atomic or mass number minus number of protons. And then also, if we're working with a neutral atom, neutral means there is no charge, the electrons have to equal protons because our negative value has to balance out our positive. If one of those two are bigger than the other, that's when we run into situations of ions. Okay. So here's a good example of looking at these different things. So your atomic number, this is on your periodic table. For example, if you find carbon, you're going to note that carbon's atomic number is 6. This has to be the same as the protons, and protons and electrons also have to match. From there, we have to have our mass number. Remember, mass number are these two added together, so that's 12. I want you to pause the video and try to do the rest, and then check your answers. Okay, welcome back. Here, let's go through, see if you guys got them right. 12, 12, and 12. And then the last one, we have 26. Well, not the last one. 26, 26, and 30. And potassium number is 19, 19, and then 39. How'd you do? Let's round this out by talking about some electron configurations. Electron configurations are where we wrote the 1s1, 1s2, 1s3. Most of you guys remembered this and did pretty well on your guys' pretest, but here's a little chart that may have helped you. Now remember, we have different energy levels, 1, 2, 3, and 4. Inside our energy levels, we have different kinds of orbitals. So most of you guys remember S, P, D, and F. Anytime you have an s, that is one orbital or two electrons. That's why you guys always write a 1s, 2. Notice this s still 1 and 2. P's, on the other hand, P's have 3 orbitals and 6 electrons. So that's why you sometimes wrote 2p6. Notice even if you go to energy level 3, they still have 3 P's and 6 electrons. D's have 5 orbitals and therefore can hold 10 electrons. And then F's have 7 orbitals and can hold 14. This picture was already given to you. It tells you the order to write electron configurations, and you remember you read it like a book. So you go left to right. 1s, and then I know there's 2 boxes here too. Here's my 2s, and there's 2 boxes. 2p, and p can hold 6 because I have 1, 2, 3, 4, 5, 6. And you just keep reading it left to right. Also, certain parts of the periodic table can be located within certain blocks. So remember, this is group 1A and 2A. This is helium. This is going to be your 3A through your 7A. And then down here, this is going to be your transition metals. And over here, we got our inner transition metals. Let's practice writing the electron configuration of calcium. So first thing you should do for calcium is determine how many electrons it has. And remember, protons equal your electrons. So if you find calcium on the periodic table, you should see that it's 20. So I have to read this left to right from 20. So if you read this left to right, I have a 1s and 2. Then I go down here to 2s and over here to 2p. So 2s can hold 2 because it's an s. 2p, remember p's can hold 6. If you go back, after 2p, you start over here with a 3s and then 3p. So 3s and then 3p6. I'm going to add up how many I've used so far. So this one's 4, 10, 11, 12, 18. So I'm at a 3p6. I can go down here to a 4s and then 2. When you add these all up, all those numbers should add up to 20, and they do. Chlorine is 17. So I want my numbers to add up to 17. So you can follow the same rule, 1s2, 2s2, 2p6, 3s2. So I have 2 plus 2 is 4, 10, 11, 12. Now my 3p can hold 6, but if I put 6 there, that gets me too many. That gets me 18. So what you have to make sure you do is that can actually only hold 5. And so that way I add up to 17. With that being said, we have these electrons constantly moving on. There are different types of atoms. Things may not be exactly neutral. The first difference is an isotope. These are things where they have the same protons and electrons, but their neutrons have differed. And this causes their mass to be different as well. Ions, which is the most important one, these are atoms where they have the same number of protons and neutrons, but the electrons are different. And that's because they've either lost or gained it. Now, making your electrons and proton numbers change can give it a charge, a positive or a negative charge. And then there are 2 types of ions that can actually form. The first one is a cation. The second one's your anion. Cation is where you lose one or more valence electrons. And when you lose a negative charge, the protons overtake, and so you get a positive cation. And these tend to be a lot of metals. Anions, on the other hand, they gain electrons. And because you're gaining a negative charge, you have more electrons than protons, so you get a negative charge. These tend to be a lot of nonmetals. Within ions, we also have polyatomic versus monoatomic. Mono just means that it consists of a single atom. So here I have just rubidium, magnesium, oxygen, or iodine. Polyatomics, poly means more than one atom. I've given you this to you already. This is examples of common polyatomics. Note that it's carbon and nitrogen here, so that's two atoms together. Down here where we have bisulfate, this is three different atoms together, hydrogen, sulfur, and oxygen. So this is considered an ion as well. Now, how do we determine monoatomic ionic charges? Well, first, know the rule. Generally, for group A elements, the group number is equal to the number of valence electrons. We've talked about that. If you're in group 1, 1 valence electron. 4, 4 valence. Group 8, you have 8. The only exception is helium, and they only have 2. Once you know that, you can look at something called the octet rule. Everybody wants to get to 8 electrons in their highest occupied energy level. They want to match a noble gas. So what happens is cations or metals tend to lose because it's easier for them to lose what they have than try to gain more. Anions tend to gain electrons because they're so close to 8, it's easier for them to take them. Noble gases on the far right, though, they have a full octet and do not generally form ions at all. In terms of transition metals, these can be a little bit tricky. And so the one thing you have to look out for is, does it have a Roman numeral written with it? So iron can actually be an iron 2 plus or a 3 plus. So in order to know, it has to tell you either by looking at a formula or it has to say iron 2. Tin and lead is something that can also have more than one charge as well. There are a few transition metals that have ionic charges. Those are silver, cadmium, and zinc. However, they don't vary. Silver will always be a +1, cadmium will always be a +2, and zinc will also always be a +2. So I believe this is the very last slide I have for you. I want you to first tell me how many valence electrons it has, and then next what charge it would have with that. So I'm going to do the first one. Lithium is located in group 1, so it has 1 valence electron. So the charge on lithium, since it is in group 1, I'm more likely to lose it, so I'm going to get a +1 charge. Bromine, on the other hand, this is located in group 7, so it has 7 valence electrons. It's easier for me to gain 1 more to get to 8, so bromine has a -1 charge. I want you to pause the video and see if you guys can determine the rest of these, and then unpause it and I can go over the answers. Okay, let's see if you were correct. So calcium is in group 2, so 2 valence electrons. That means that calcium is easier to lose 2 than try to get 6 more. So calcium is a 2 plus. Krypton is in group 8, so it has 8 valence electron. But it's not going to form an ion, so it just stays krypton. Nitrogen is part of group 5A, so it has 5 valence electrons. And it's easier for it to gain 3 than lose those 5. So nitrogen tends to be a 3 negative. Aluminum is in group 3, so 3 valence electrons. The charge that you guys get is 3 plus because it's going to lose those 3, then try to gain 5 more. Sulfur is in group 6A, so 6 valence electrons. Sulfur is a 2 negative. And potassium, this is in group 1, so 1 valence electron. And so the charge that it tends to give you is a +1. How did you guys do? That is the end of today's lesson. Let me know if you have any questions, and I hope you have a great day.